In this section, we're going to talk about permutations. Permutations, this is basically a continuation of the previous section on basic counting principles. So at least the very beginning of this will look very, very familiar. A permutation, by the way, is basically an ordering or an arrangement. How many ways could you arrange a certain number of books on a shelf, for example? So let's start off at the beginning here. A library receives a gift of 10 antique books, and they want to display or arrange 3 of them in 3 given locations in the library. Say, here, here, and here. Those are the 3 locations. How many different arrangements are possible? So we've got 10 antique books. I'm going to put one here, here, and here. How many different ways could we do that? Well, activity 1 is to choose one of the 10 books. And let's say we put that one here. So we would have 10 different choices for this location right here. Now we'll come down to this location. Activity 2 is to choose one of the 9 remaining books. And maybe we put that one right here. And then activity 3 is to choose one of the 8 remaining books. And maybe we have 8 choices right here. So using that multiplication principle, the number of possible ways that we could arrange 3 of those books is 10 times 9 times 8. So let's see, that was pretty easy. That's 72 with an extra 0. 720 possible arrangements. Now, suppose there are 10 elements in a set. Okay, it could be anything. It could be the first 10 letters of the alphabet. It could be the numbers 1 through 10. It doesn't matter. 10 elements in a set. How many different ways can you select one element at random from the set? Well, if you have to select one of them, and there are 10 choices, that could happen in 10 different ways. And then, how many ways could you select a second element from the remaining set after you've removed one? Well, there are 9. And select a third element, well, that would be 8. And select a fourth element, that would be 7 ways to do it. So you just keep subtracting one each time, because when you select one, it's no longer available to be selected again. You select the second one, it's no longer available to be selected again. So now, let's use a variable. Suppose I didn't know that there were 10 elements in this set. I was just told we have a set. And let's just let n be the number of elements in the set. If I were to answer these 4 questions again, how many different ways could I select one element at random from the set of n elements? Well, there are n of them. I don't have to know what that number is. I'm just going to use it here. There are n ways to choose it. Now, how many ways could I choose the second element from the set? We've removed one from this set of n, so there's only n minus 1 for the second one. And then for the third one, well, there's only n minus 2 ways to choose, and n minus 3 to choose the fourth element. And again, if you replace n with the number 10, you get exactly these 4 numbers: 10, 10 minus 1, 10 minus 2, and 10 minus 3. Which gives us those numbers. Okay, now a subset, let's remind ourselves what a subset is. If you have a given set of items, a subset is choosing any number you want of the items from that set. So if you choose one item, that's a subset. If you choose the first and the third, that's a subset. If you choose the last one and the first one, that's a subset. Any number of elements could be considered a subset. So a subset of distinct elements selected from a given set and arranged in a specific order is called a permutation. For example, let's take this given set, 1, 2, 3, 4, 5, 6, 7, 8, with 10 elements in it. That seems to be the theme of our problem so far. 10 elements here, the letters, lowercase letters A through J. Some of the permutations of 3 elements would be this: DGH, D, G, and H. Now notice this is another permutation. It's brand new. It's completely different from this. Well, completely different. It uses the same elements, but it's in a different order. The permutation order matters. Here's another permutation, A, B, and C, the first three elements in that order. AKB. Oops, there is no K, so I'm going to change that to AHB and BAH. Okay, so that's AHB, BAH. I'll just scratch those out. So basically you could choose any three from this set. That would be a subset, and then put them in a particular order, and that gives you a permutation. A permutation of 3 elements taken from this set of 10 elements. Can you tell me how many 3 permutations are there? There are. 3 permutations basically has 3 elements. How many permutations could I have by taking 3 elements out of here and putting them in a particular order? Well, this is really quite simple to compute. 1, 2, 3. How many choices do I have for this first term? 10. I could choose absolutely any one of them that I want. How many could I choose for the second one after I've chosen that one? I've got 9, and then I've got 8. 720. So the number of 3 permutations, remember that just means 3 elements, chosen from this set is 720. Now, I'm going to remind you, a permutation is an arrangement. It's an ordering. So ABC is not the same as CBA or BAC or BCA. Every arrangement is a different one. All right, to finish this up, it looks like we're going to use this number 10 again. There are 10 runners in a race. In how many ways can first place, second place, and third place prizes be awarded? Well, you've got a first place, you've got a second place, you've got a third place. I'll even write first, second, third. Out of the 10 runners, how many of them could possibly come in first? Well, any one of them. 10. And then after that person crosses the finish line, you've got 9 possibilities for second, and you've got 8 for third, and once again, you've got 720 possible ways. So there are many, many ways you can ask this question. And it would have 720. I could say, if you've got 10 books, how many ways could you take 3 of them and arrange them on a bookshelf? The answer would be 720. If you're arranging 3 of them, there's one that would be on the left, one that would be in the center, and one that would be on the right. You got 10 choices times 9 choices times 8 choices. Permutations.